Hey, what's going on? Um, we are going to move right on to Essential 4 today, okay? We didn't take a lot of time with Essential 3. That was the graphs and variables and axis. I think that's a lot of review. I told you that we would kind of do this pretty quick, so short lecture. But Essential 4 is one-dimensional motion, all right? It's kind of like objects in motion. How fast do they move? What's their acceleration? We have to talk about what the difference is between displacement and distance, all right? And we also have to talk about two types of quantities or measurements known as vectors and scalars, okay? And so we'll do all that. Also as well, I'll introduce what are known as the kinematic equations. We use those to solve word problems when we talk about one-dimensional motion, okay? So if you were to go to your Mastery Essentials list, you'll see this is number 4, all right? And that's what we'll cover today, all right? Real briefly, shouldn't take long. Let's see if I can get out of there. There we go. Here, let's start a real quick PowerPoint, okay? Essential 4, one-dimension motion, all right? And so these are the equations. Go ahead and pause it for a second and jot down the 3 kinematic equations. They look extremely difficult, but when you get in the hang of using them, they're not that bad, all right? So go for it, copy those down. All right, let's talk about what these letters stand for. You've got a V with a little 0 at the bottom there, a little subscript. You got an A, a T, and an X. All right, so the original V there, if you see a V in one of those equations, it just stands for velocity. All right, but if you see the V with a little O down below it, we call that an initial velocity. And what I mean by initial velocity is right now this tennis ball has an initial velocity of 0, okay? However, and it'll have a velocity when I drop it. However, if I take that same tennis ball and I throw it down, okay, maybe at that point now it's got an initial velocity. It's got a velocity before I let go. And so now there's some number associated with how fast is it moving when it starts, okay? A stands for acceleration. Acceleration is a real easy concept. It just means that something is getting faster or slower over time, or it's changing direction. It's important, changing direction. All right, T is for time. X means distance in the X direction. I should be careful there. Distance, would you please put in parentheses displacement? All right, displacement in the X direction. So right here, this is displacement in the X direction. Little error on my part, but I know you'll change it for me. All right, types of quantities. Quantities or values of measurements come in one of two forms. We call them either vector quantities or scalar quantities. All right, well, what's the difference between a scalar and a vector? Next slide, okay? Sorry, I didn't pause too much there for you to write down those notes. Scalar versus quantity, here we go. All right, scalar quantities are quantities that require only a value or a magnitude. It's like saying, outside it's 35 degrees Fahrenheit or it's 80 degrees Fahrenheit. That's all required about temperature. It's just telling me how much, all right? We're going to see that a vector quantity is a little bit different than that, all right? Speed is an example of a scalar quantity because all you need is a number. You can say that, for example, the car is moving 38 miles per hour. You're done with that quantity. All you do is tell me how much. How much is it, how fast is it moving? How warm is it outside, okay? Vector quantities are a little bit different, all right? Vector quantities also require a direction, and velocity is an example of that. It's a vector quantity. And so instead of just saying that something is moving so fast, you also have to say in what direction is it moving. And so my example here, the tornado is moving 22 miles per hour in the northeast. If I'm at home and I hear that a tornado is approaching, I'm going to want to know what direction is it coming from, okay? Speed, how fast is the tornado moving? Velocity, how fast and in what direction, okay? So two types of quantities. We'll look at some other examples of those here in just a second, okay? Displacement and distance, one of those is a vector quantity and the other one is a scalar quantity, okay? And so there's two types of measurements here. They're a little bit different. If I drive a mile to the store and back, see, I traveled a distance of 2 miles. But when you look at the definition of displacement, you're looking at how far did you move from your origin. All right, so you got to know the definition between the two. Distance is how far did you travel. Displacement is how far from your origin did you end up. And if you end up in the same spot that you started, then you have a displacement of 0, okay? Here's the difference in just a real quick visual, all right? The purple line here, following it, you can see that you traveled quite a long distance, but from your origin, there's the straight line. How far did you move? All right, and if we talk about displacement, there would be some value, and there would also be in what direction. All right, distance has nothing to do with direction, so it's a scalar quantity. Displacement is how far from your origin did you end up, and in what direction. Okay, so distance, scalar quantity, displacement, vector quantity. I'm kind of moving quick, but I told you this would be a quick one, okay? I want you to understand these concepts for tomorrow's lab, all right? Examples. What is the displacement of the cross-country team if they begin at the school, they run 10 miles, and finish back at the school? Well, if we're looking at displacement, what did you just find out about displacement? How far did they move from their origin? So yeah, they ran 10 miles, but they ended up right back where they started. Big old displacement of nothing, okay? 0. See the ball? All right, I may chuck it against the wall, but if it comes back to me, my displacement's 0, okay? It may have traveled 8 total meters, but it had a displacement of 0. Another question, another example. What's the distance and the displacement of the race car drivers in the Indy 500? Well, when you look at the question, it wants both. Okay, what's that 500 stand for in the Indy 500? It stands for how many miles they have to go. That's the distance covered, all right? But as far as displacement's concerned, they start and they stop virtually in the same position at the same point. And so really, as far as displacement's concerned, we're again at 0, okay? I hope you're writing everything down. Please pause along the way, all right? Just some other examples of scalar quantities. We said speed, all right? We also said distance, but temperature and mass and charge. When I talk about charge, I'm talking about positives and negatives. It wouldn't make sense to put a direction in any of those, all right? But vector quantities, if you look at them, velocity and acceleration and force, you can say that I'm pulling on the rope with 50 newtons of force, okay? And I'm pulling to the right, or I'm pulling in a west direction or an east direction or whatever. So vector quantities require a direction as well as how much, okay? All right, so there's that PowerPoint. I do want to show you real quick a little YouTube video if I can find it, okay? Take a look and watch real quick. About a minute here, little halo. Somebody made this, I didn't do it, but I like it. All right, so now you add all those up. You figured out what his distance was, but did he stop where he started? He does, so his displacement is nothing. Distance covered, though, a little bit different. You'll have to add it all up. His displacement would be, nice. His displacement is the straight line distance from where he started, okay? Because it's displacement, you'd also have to tell me what direction he ended up in, all right? Did he end up in a north, it looked like he was traveling northwest from his origin. Okay? So, to wrap this up, you got to know two types of quantities, scalar and vector. You got to know that displacement is a vector quantity, and you have to know that distance is a scalar quantity. Also, speed and velocity. Now back to this slide here, I understand that we didn't do anything with them right now. I just want you to have them written down, okay? When you come in tomorrow, I'm going to have you do a lab. That lab is going to cover the differences between distance and displacement, so you'll be able to work through those, okay? So we'll do the lab tomorrow. We'll also make sure that we get the homework, well, sorry, not homework, Physics Problems 101, that worksheet handed in, okay? That's it. We'll call it a lecture at that point there. All right, we'll see ya.